Hello, this is EC544 Group 13 presenting the video for Challenge 6, Indoor Localization. And I am presenting Aparna. As you know, our challenge was to create a system to localize a mobile device indoors and display the results on a unconnected device. So the important design decisions we took were to use XPs because we weren't sure how the network coverage would work with the photons. And since we had 5 XPs, we used 4 of them as beacons to get the maximum accuracy from the parts we had, and the 5th one was on the mobile device. We used the KNN localization strategy to plot where the device was in the test area. We trained separately for X and Y coordinates so that we would be able to get good resolution of the device position rather than using bins. After testing the training data with a number of different Ks, we realized that K equals 1 was giving us the best performance, so that's what we ended up going with for prediction. On the software side, we used a Node.js server because it could communicate directly with the XPs and the website, and we used Google Charts to animate the display of the current and previous locations of our mobile device. So these are the components we ended up using: XBs, Arduinos, Raspberry Pi, and battery packs. This is our system overview. So we have 4 beacons deployed in the 4 corners of the test area. Each of them is a Arduino with a power supply and a XP in router API mode. Then the mobile unit is the Raspberry Pi running the Node.js server, and it's connected to the XP coordinator also in API mode. And the Node.js server queries the beacons every 2 seconds to meet the time requirement. Then it feeds the RSSI values to the machine learning module and predicts the location with KNN, and then sends the location data to the website. We had the website accessible off network with DDNS, so it could be accessed from a phone or a laptop. This is just a picture of our localization system, the beacons and router, Pi, laptop. And this is what our website looked like. In addition to showing the current location with the biggest, darkest dot, we showed the last 10 locations, so you could see how the device was moving around the area. And the challenges we faced were configuring the XBs. We tried a bunch of different firmwares before we got something to work. We found the RSSI signals were not very reliable, so we tried to mitigate that by moving the frequency of the XP and moving the location to the 5th floor, which was quieter. We had a couple of last-minute hardware failures, but we managed to overcome them and present on time with an adapted system for 3 beacons. And this is the contribution of each of us, and thank you. This is a video of our localization system for the mobile Pi with the coordinator being in a stationary position. You can see that on the website there's a very stable dot at this corner that shows where the Pi is, and you can see that we have it on DDNS accessible to outside network. Here you see it's accessible on a mobile phone, the same website, and in terms of the position, you can see we're really close to the corner of the building, and that is exactly what we see on the screen here. Here is a video of the Pi being carried up and down the corridor. Mo is carrying the Pi, he's walking away, and you can see that the position updates in the corridor. The biggest, you can see the biggest dot moving towards that end of the corridor as he moves away, and now he has reached the end over here. And you can also see the trace of the movement where he has been on his way.